Hello friends, in this video we will talk about multiplicative inverse, but before that let's talk about modular division. So definition says given a is not equal to 0 and b, there exists x such that a times x is congruent to b mod n. So that means we are supposed to find out for given values of b, a and n, given values of b, a and n, we are supposed to find out x such that a times x is congruent to b mod n. So that means if you perform mod operation on a times x with n, if you perform modulo n operation on ax, then you must get b as the remainder. Okay, so before we discuss this, let's consider the traditional division. So in traditional standard mathematical division, we talk about b divided by a, and let's say the constant is if these values are integers, let's say b and a are integers, then our x must be also integer. Then in some scenario this is feasible. For example, if b is equal to 4 and a is equal to 2, then we will get 4 by 2, which is nothing but 2. But in some cases this division is not possible. For example, if we perform 5 by 2, then we won't be able to generate integer value. This value is real, right? 2.5. So similar to this, let's try to analyze what will happen in the case of modular division. So let me take one example first, then we will discuss further. So let me take modulo 5 example. So that means value of n is 5. So these three values are given, a, b and n. These three values are given and we are supposed to find out x. Okay. So x is, in other words, we can also write like this: x is congruent to b divided by a mod n. Okay, so n is equal to 5 in this particular case, and let's say value of a is 3. Okay, and value of b is, which is nothing but remainder. So remainder can be anything from 0 to 4, because so in general we can say that b, range of b is from 0 to n minus 1, because if we perform mod n, then mod n answer, right, mod n answer cannot be, can be at most n minus 1, right? So this is the range for b. So in our case the answer can be 0 to 4, right? So let me pick one value. So let's say I'm saying answer is 2. So now from this table, let's try to derive the answer, which is nothing but value of x. Okay, so now this row values are corresponding to values of a, and here value of a is 3 given, so I am referring to this particular row. This values, which are nothing but column values, they are corresponding to value of x. So we are interested in finding out that particular value x. And so basically let me take some pairs. For example, if I take a is equal to 3 and x is equal to 2, then 3 into 2 is nothing but 6. So this is nothing but multiplication sign. 3 into 2 is 6, and if I take mod 5, then I will get 1. So this 1 is corresponding to pair 3 comma 2, right? So I want my answer to be 2. So that means this values, right, this 5 values are corresponding to 5 possible remainders, right? So you can check. So it is ranging from 0 to 4 in this particular case, and I am interested in b is equal to 2. So that means I am interested in this particular value, right? So my remainder is 2, a is 3, then corresponding x value is nothing but 4. So let's verify whether this is correct or not. So basically 3 into 4, right? 3 into 4 is nothing but 12, and if I perform 12 modulo 5, actually I am getting 2, right? So this so basically what we have done, we have just performed division operation. So which division we have performed? If we consider this particular terminology, then we have found out x, which is congruent to b by a mod n. So in this particular case, value of b is 2, value of a is nothing but 3, and value of n is nothing but 5, right? And our answer is nothing but value of x, which is nothing but 4. Okay, so 4 is congruent to 2 divided by 3 mod 5. So now if we analyze this further, then we can see some pattern over here. For example, there are 5 different values of reminders are possible when we do modulo 5 operation, and all those values are present in every row except 0, because a is anyway not equal to 0, so we are going to ignore this particular row. So except this particular row, you can observe that all these 5 values are present. So each row is nothing but permutation of 0 to 4, these numbers, right? So that means you can take any value of b and still division is possible in this particular case. So one can ask, is it always the case, or we can get some scenario where this particular division is not possible, this type of division is not possible? So let's check it out. So now instead of mode 5, let me draw a table for mode 4. So in mode 4, 4 different answers are possible with respect to remainder, and they are nothing but 0, 1, 2 and 3. And if you observe, though number 2, which is nothing but corresponding to a is equal to 2, then only 2 reminders are present. Reminder 1 is not present, as you can see, as well as reminder 3 is not present. So that means what we are trying to say here is, let's say, let me give some values. So let's say value of a is equal to 2, okay, and I want remainder value to be 1, and definitely n is equal to 4 because we are considering mode 4 operation. Then this division, so here we are talking about division of b by a, so which is nothing but 1 by 2 mode n. We need to find out x such that x is congruent to 1 by 2 mode n, where n is nothing but 4 in this particular case, right? In other words, we are interested in finding out 2 times x, okay, 2 times x, such that if we perform mode 4 on it, then our answer is nothing but 1. Okay, so 2 times x must be congruent to 1 mode 4. But if we see this particular table, then a is equal to 2, and if we check with respect to remainder, then there is no value 1, right? 1 is anyway not present in this particular row. So there is no x such that this type of division is possible. And if we simplify this, then we'll be able to get insights why this is not possible. Because if this is possible, then basically we are saying 2x minus 1 is multiple of 4, and 2x minus 1 is an odd number. An odd number cannot be multiple of 4, so therefore we are not getting this type of value, which is nothing but b is equal to 1 in this particular case. We won't be able to generate x such that this configuration is correct, right? So now let's see the definition of multiplicative inverse. So that means this modulo division is not always possible, right? In some cases it's possible, in some cases it's not possible. In the next video we'll talk about multiplicative inverse in detail. Thank you. Subscribe to my channel for more videos.